Hello students, I hope you all are doing well. Now today we are going to meet once again with another new unit of class 12 chemistry, and that is general principles of extraction and isolation of elements. So in this chapter children, we'll be dealing about the metallurgical operation, that is how to extract a metal from its ore. So before we proceed into the detail of the chapter, let me just make you aware with the basic concepts. The basic terminologies involved in the chapter are minerals, and you all might have come across this term minerals, which is actually the naturally occurring chemical substances in the earth crust which are obtained by mining. And ores are actually those minerals from which we can extract the metals conveniently, profitably, and economically. The ores are actually in the impure form, and the impurities associated with the ore is called the gangue. If you look at the occurrence of metal, we have studied in the lower classes that if it depends upon the reactivity of a metal, that if the metal is highly reactive, it tends to occur in the combined state. But if it is least reactive or less reactive, it occurs in the free state. So here are some of the ores of the various metals. For example, aluminium, the most important ore is bauxite. You can see the formula Al2O3.2H2. Iron, the important ores are hematite and magnetite. Just look at the formulas and just review. These are a few important ores of various metals. Copper, we have copper pyrite, CuFeS2. Other ores are copper glans and cuprite. Zinc, we have zinc blende, ZnS. Calamine, which is ZnCO3, that is the carbonate ore of zinc. Now, if you just see metallurgy, metallurgy is actually the process of extracting or isolating a metal from its ore. And just now we discussed that ores are those earthy substances from which we can extract the metals profitably, conveniently, and economically. Now, ores, as we discussed, that they are present in the impure state. So the first and foremost process is actually the concentration of the ore. The concentration of the ore involves the removal of the gangue from the ore, and this method of concentration is also called ore enrichment or ore dressing or ore beneficiation. Please note down ore enrichment, ore dressing, ore beneficiation, which is actually the concentration that is to remove the unwanted impurity, that is the gangue, from the ore. Now we have four different methods of concentrating the ore. The first method is the hydraulic washing. The hydraulic washing, now in the board exams, what is actually asked is, children, the basic principles of the concentration and the refining methods, which we will discuss later on. This chapter, remember, carries a weightage of 3 marks, and two very important type of questions comes: basic principle of various concentration and refining method, and the role of various substances involved. So we will discuss as we proceed with the chapter. I'll be telling you what important questions comes in the board examination from this chapter. The very first concentration method is hydraulic washing. You have to remember that the hydraulic washing process, the basic principle is the difference in the densities or the gravities of the gangue and the ore. The ores are actually heavier and the gangue is lighter. So what is done? A jet or stream of water is allowed to pass through impure ore so that the heavier ore particles are left behind and the lighter ore particles are washed off by the stream of water. And this method is applicable for the concentration of the oxide ores, which are generally heavy. They are concentrated by the process called hydraulic washing, also known as gravity separation or levication. Hydraulic washing, called gravity separation or levication. The next method of concentrating the ore is the magnetic separation method. The magnetic separation method is the basic principle of this method is difference in the magnetic property of the ore and the gangue. Normally the ores are magnetic in nature and the gangue is non-magnetic in nature. This method is done, this is the setup of the magnetic separation method. There are two types of rollers. The first one is the non-magnetic roller and the another one is the magnetic roller. On these two rollers run the conveyor belt made up of vulcanized rubber, and when powdered ore is dropped on this conveyor belt, and when this conveyor belt moves, the ores, when the magnetic ores, when they come in contact with the magnetic roller, are being attracted towards the magnet, whereas the non-magnetic gangue particles, which are not attracted towards the magnet, are collected in separate heap. In this manner, the non-magnetic gangue is separated from the magnetic ore. So these are the two methods, and now we move on to the next, and that is the third method, which is called froth flotation method. The third method of concentrating the ore is the froth flotation method. It's a very, very important method, and the basic principle of this method is the difference in the wetting property of the ore and the gangue. Actually, the ore is wetted by oil and the gangue is wetted by water. Now, in the froth flotation process, a tank or a vessel is taken in which this method is actually applicable for the concentration of specifically sulfide ores. The reason being that the sulfide ores have a strong wetting property towards the oil. So, in this method, a tank is taken, and in this tank, powdered sulfide ore is mixed with the pine oil. Pine oil, the role of pine oil we will discuss, it acts as a collector. So the pine oil and the cresols or aniline, the role of cresols or aniline added in this process, they act as froth stabilizers and they stabilize the froth for a longer period of time. Now, in this process, a jet of compressed air is allowed to pass through, which agitates the mixture. As a result of agitation, froth is produced and froth floats on the surface. To the froth, since the sulfide ores have a strong wettability towards the oil, they stick to the froth present on the surface, and this froth is then skimmed off from the surface to recover the sulfide ore particles. The gangue particles which are wetted by water remain at the bottom, and in this manner the gangue is separated from the sulfide ore particles. Now, in board examination, often three very, very important questions come relevant to this froth flotation process. One is the basic principle of the process. Remember, it is the preferential wetting of the ore by oil and gangue by water. That means the difference in the wetting property of the ore and the gangue. Ore is wetted by oil and gangue is wetted by water. Another very important one mark question which comes from this is the role of collectors in the froth flotation process. Collectors are the pine oils or the xanthates. They act as collectors and they collect the froth on the surface, or they enhance the non-wettability of the ore. So the role of collector is to impart the water repellent properties to the surface of the ore particle to be floated on the surface. Next, the important substances which are added to the tank are the cresols and aniline. Cresol and aniline behave as froth stabilizer and they stabilize the froth for a longer period of time on the surface so as to easily recover the sulfide ore particles. The third substance which is added normally to this process is the aqueous solution of NaCN or maybe KCN, which acts as depressant. The role of depressant is it acts as a gate. It selectively prevents certain type of sulfide particles from coming to the froth. For example, if you add NaCN and if you are asked to separate a mixture of ore containing ZnS and PbS, then NaCN will act as a depressant and it will allow only PbS to stick to the froth and will not allow ZnS to stick to the froth. By combining with the ZnS, it forms a soluble complex and hence prevents the zinc sulfide to stick to the froth. So this is the very important third method of concentration, which is called the froth flotation process. And now we come to the fourth concentration method, which is called chemical separation or leaching. This chemical separation or leaching, the basic principle is that the ore, when dissolved in a suitable reagent, forms a soluble complex, but the impurity or the gangue remains undissolved in the reagent. A suitable reagent which can selectively dissolve the ore but not the impurity. This is the basic principle of leaching or chemical separation. Now in this leaching, let us take the example of the leaching of aluminium from bauxite, and the name of the process involved is the Bayer's process. Bayer's process involves the three steps. The three steps are the treatment of impure bauxite with NaOH. Aqueous NaOH here acts as a leaching agent. This question comes for 1 mark in the board examination. What is the role of caustic soda or NaOH in the concentration of the bauxite ore by Bayer's process? It acts as a, remember, leaching agent. Means it is able to dissolve the ore but not the gangue. So when it reacts with the impure alumina, it forms a soluble complex which is sodium tetrahydroxoaluminate third, NaAlOH whole 4. Then this complex tends to react with CO2 so that it forms hydrated alumina, Al2O3.xH2O. Finally, this is ignited at a temperature of 1470 Kelvin so as to convert into pure alumina. So here the ore is reacting with the leaching agent to form a soluble complex, but the gangue remains undissolved in the reagent. So these were the 4 methods. Let us recall the first method called gravity separation, the second method called magnetic separation, the third method froth flotation, exclusively applicable for the concentration of sulfide ores. The fourth method is the chemical separation or leaching. Now in case if the ore is not in its oxide form, if suppose it is in form of sulfide or carbonate, it needs to be first converted into oxide, and how it is done either by the process of calcination or by the process of roasting. So calcination and roasting you have studied in class 10th also. It is calcination involves the process of heating an ore in the absence or limited supply of air, and calcination ensures to remove moisture from the ore, making it anhydrous, that means hydrated ore becoming anhydrous. It also involves the treatment of the carbonate ores. Carbonate ores are actually heated in the absence of air, and carbonate ores when heated in the absence of air convert into corresponding oxides. For example, if you just see the carbonate ores, for example limestone, when it is being heated it is converted into calcium oxide releasing carbon dioxide. So in calcination, CO2 gas is being involved. Remember, it is applicable for carbonate type of ores, and this moisture is removed in this case and the hydrated ore becomes anhydrous. If you see roasting process, roasting is just reverse of calcination, and it is applicable for the sulfide type of ores. Roasting will involve the heating of the sulfide ores in the presence of air. In the excess of air, when sulfide ores are heated, moisture is removed, organic matter is removed, and the non-metallic impurities such as sulfur, phosphorus, arsenic are oxidized. Sulfide ores are converted into oxide and SO2 gas is removed in the process. Now, let us see after calcination or roasting, the ores have now been converted into the oxide form. So, oxide form of ores, from these ores, what is to be done is the reduction of these ores is to be carried out. The reduction involves the 6 different methods. The very first method is the auto reduction. Auto reduction is actually applicable for the less reactive metals. The less reactive metals, when subjected to auto reduction, for example copper, mercury, etc., then they eliminate oxygen and they convert into the copper. Now here you have to see these 2 sets of reactions. For example of copper, if you see Cu2s when reacting with oxygen that is undergoing the process of roasting first converts into Cu2O, releasing sulfur dioxide. And when this Cu2O which is formed reacts with unreacted Cu2S, it converts into copper, and this copper thus formed is called blister copper. The reason for this being called as blister copper is that the SO2 gas which is evolved develops blister on the surface of copper, and hence this blistered copper having blistered appearance is called blister copper. Now the second reduction method is the method of smelting. Smelting involves the treatment or the reduction of metal oxide using coke or carbon monoxide as the reducing agent. Coke or carbon monoxide is used as the reducing agent. Reduction process is the process using aluminium as a reducing agent. The process using aluminium as a reducing agent is called Aluminothermic Process, or also called Goldschmidt Aluminothermite Process. In this process, the metal oxide is reduced using aluminium as the reducing agent. For example, we have learned this in class 10th also, and this method finds its application in joining the railway tracks and is known as thermite welding. It is called thermite welding, and why it is used for welding purposes, because for example, if you are reducing the ore of Cr2O3 or let us say Fe2O3 using aluminium as a reducing agent, or MnO4 using aluminium as a reducing agent, then aluminium itself will get oxidized to Al2O3 and reduce the corresponding metal oxides to metal, and in this process a large amount of heat is released, and this heat basically melts the metal and when cools get solidified and hence helps in the welding process or the welding purpose. So this is the third reduction process using aluminium as a reducing agent and called the Aluminothermic process. The next is using the hydrogen as the reducing agent. Reduction using hydrogen, and this is often used for the oxides of molybdenum and tungsten, where the molybdenum or tungsten oxide by using hydrogen as the reducing agent converts or gets reduced into corresponding metals like molybdenum and tungsten. The next process is the process of hydrometallurgy reduction process, which is called hydrometallurgy process. And in this process, the extraction of metal is done by dissolving the ore in the suitable reagent, resulting in the formation of a soluble complex, which is then treated with a highly electropositive metal, which tends to act as a reducing agent. These two reactions are very, very important, and these reactions are the reactions of the leaching of the gold and the silver type of ores. The name of the process is MacArthur Forest Cyanide process, where NaCN, aqueous solution of NaCN in the presence of air or oxygen is used, which reacts with gold or silver to form a soluble complex, and then this soluble complex is treated with the highly electropositive metal called zinc. Zinc tends to act as reducing agent, and it helps to recover the native ores of the metals from their native ores, that is gold and silver. This process is called hydrometallurgy, and this specifically used for the separation or the removal or isolation of the gold and silver metals from their native ores. The next process is the electrometallurgy process. An electrometallurgy reduction process involves the electrolytic reduction or electrolysis of the fused salt of the metals, and this process is called electrometallurgy. We will study later in the next slide about this electrometallurgy process. So now let us talk of the flux. Flux, what is a flux? Flux is actually a substance which, when added to the ore, combines with the gangue and removes the gangue in form of the slag. So flux is a substance when mixed with the ore combines with the gangue to form a fusible mass called slag. And the flux is of two different types. What are the two different types of flux? The acidic flux and the basic flux. For example, in the metallurgy of copper, let us talk about the acidic flux. The silica acts as the acidic flux. So that whatever impurities of CaO or FeO are present in the copper ore, it will combine with the acidic flux silica to remove it in form of a fusible slag, for example calcium silicate or maybe FeSiO3 ferrous silicate. Then flux is of another type, and this is called the another type of flux are the basic flux. The basic flux are the flux which are used to remove the acidic impurities. For example, in the metallurgy of iron, the acidic impurity present is silica. So when basic flux limestone is added to that, in board examination it is asked that what is the role of limestone in the metallurgy of iron to extract iron from hematite ore. It acts as a basic flux. It combines with the acidic impurities of the silica to remove it in form of fusible slag called calcium silicate. The last step of metallurgy is the refining. Refining of the ore refers to the removal of the impurities from the metal. Refining of the metal, the last step, that is to remove the impurities from the metal, is done by 6 different methods. The first method is the distillation method. Distillation method, the basic principle of this method is the difference in the boiling point of the metal and the impurities. The metal has low boiling point in comparison to the impurities. So the low boiling metals are refined by using the process of distillation, for example, cadmium and mercury. The next process is the process of liquation. Liquation involves the basic principle of liquation process is the difference in the melting point of the metal and the impurity. The metals have low melting point in comparison to the impurity. So this method is actually used for the low melting metals like tin and lead. The third refining method is the electrolytic refining. The basic principle of electrolytic refining process is that a thick rod of impure metal acts as anode, a thin strip or thin rod of pure metal acts as cathode, and the soluble salt of the metal acts as electrolyte. So, what actually happens is the metal from the impure anode, that is the thick rod of impure anode, via the electrolyte moves to the cathode and gradually deposits on the cathode, and finally all the impurities are left behind at the anode in form of anode mud. And this method is applicable for the refining of copper, gold, silver, zinc, aluminium, etc. So remember, in the basic principle you have to write 3 things: the thick rod of impure metal acting as anode, the thin rod of pure metal acting as cathode, and soluble salt of metal acting as electrolyte. The next method is the zone refining method. The zone refining method, the basic principle is, remember, very important method, impurities are more soluble in the molten state than in the solid state of the metal. So what is done is a rod of impure metal is taken. A rod of impure metal is enclosed in the glass tube, and circular heaters are allowed to pass through the glass tube. By the heat of the circular heaters, the metal melts. And since the basic principle is that impurities are more soluble in the molten state, so impurities get dissolved in the molten state, and when the heaters move ahead, the molten zone along with the impurity also moves ahead. And finally, when it comes at the end, it is discarded and leaving behind the pure metal. So this method is actually applicable for the refining of semiconductors, for example, silicon, germanium, boron, and gallium. The basic principle, very important to remember, impurities are more soluble in the molten state than in the solid state of metal. The next refining process is the vapor phase refining. The vapor phase refining, the basic principle of this is that metal reacts with a suitable reagent to form a volatile compound, and that volatile compound thermally decomposes to give back pure metal. So this vapor phase refining is subdivided into two sub-methods, that is the Mond process, exclusively applicable for refining of nickel, and the Van Arkel, applicable for the refining of zirconium and titanium. In the Mond process, the impure nickel is treated with carbon monoxide, which forms a complex, a volatile complex, that is tetracarbonyl nickel. And this tetracarbonyl nickel decomposes to give pure nickel, releasing the CO in form of a gas. Next is the Van Arkel method. Van Arkel method is exclusively applicable for zirconium and titanium. The zirconium and titanium, they are treated with iodine. The Van Arkel method involves the treatment of zirconium or titanium with iodine so as to form a volatile complex zirconium or titanium tetraiodide, which when heated breaks down to form pure zirconium or pure titanium, leaving behind iodine gases. The next refining method is the chromatographic method. The chromatographic method involves, the basic principle of this method is the differential extent of adsorption of the metal and the impurities on a suitable, maybe column, on the suitable surface of suitable column. So this is how the metal the impurities get separated from the metal. The last method is oxidative refining, where the impure metal is heated to a high temperature and then exposed to air, where impurities such as carbon, phosphorus and arsenic are oxidized, and oxidative refining of iron is carried out in a Bessemer converter by blowing air through the molten metal. So lastly, let us see whatever we have studied in a nutshell. Let us see that the first step, this is the flow diagram or the flow sheet diagram for the metallurgical operation. First of all, the ore that is crushed and grinded by the process called pulverization, so that it comes into the powdered state, and then this powdered ore, which is actually impure, is subjected to concentration. Concentration, as I discussed, is also called ore enrichment or ore beneficiation, and there are four different methods of concentration. First is the gravity separation, or also called levitation. So another method is the magnetic separation. The third method, froth flotation. The fourth method, leaching or chemical separation. Now, once we have removed the gangue from the ore, we have obtained the concentrated form of ore. If suppose it is in form of carbonate, it is subjected to calcination, that is heating in the absence of air, so as to convert into metal oxide. Or if it is in form of sulfide, it is subjected to heating in the excess of air, so as to, by the process of roasting, so as to convert it into the oxide form. And now, once we have got the oxide form of ore, we need to remove oxygen from it by the process of reduction. So here are the 6 different methods of reduction. Auto reduction, used for less reactive metals. Then smelting, where we use carbon or carbon monoxide as the reducing agent. Reduction using hydrogen for the oxides of molybdenum and tungsten. Aluminothermic process, where we use aluminium as the reducing agent. Electrolytic reduction, and hydrometallurgy, involving the MacArthur forest cyanide process. Finally, we obtain the impure metal, and impurities associated with the metal are removed by the process of refining. Refining involves the 6 different methods. The important are the 6 methods. Distillation, based on the difference in the boiling point of the metal and the impurity. Liquefaction, based on the difference in the melting point of the metal and the impurity. Electrolytic refining, zone refining, exclusively applicable for semiconductors. Vapor phase refining, which are of 2 types, Van Arkel process for zirconium and titanium, and Mond process for nickel, and chromatographic process, which is based on the differential extent of adsorption of the metal and the impurity. Finally, we obtain the pure metal, and this is all about metallurgy, children. Read the chapter thoroughly, just go through the content once again, and have a nice day.